Pole kabisa. Basi basi. Oh. Moja ya mwisho.
Shika upanga wako, mukate, mukate. Shika upanga wako, mukate pepo. Shika upanga wako, mukate. Ala upanga, mukate. Shika upanga wako, mukate pepo. Shika upanga wako, mukate.
Malaria has a major impact on the health and well-being of sub-Saharan Africa. Millions contract the illness each year. Several 100,000 die as a consequence. For some survivors, long-term physical and mental impairment reduce the quality of life. Productivity goes down for individuals, families, nations, and ultimately, this negatively impacts the economy of my Africa. There are many ways to control malaria. Reducing contact with mosquitoes that transmit the disease is one of the most important ways in which this is done, through the use of bed nets and insecticide spraying, amongst others. The proper diagnosis and treatment of malaria is also important. However, vaccines are the most effective and cost-effective public health interventions for infectious diseases. Our dream is that one day a highly effective malaria vaccine will become freely available to the most vulnerable in Africa. So what causes malaria? Parasites of the Plasmodium falciparum species are responsible for most of the malaria infections in Africa. An infected mosquito injects the parasite into the skin, from which it finds its way into the liver and ultimately into the bloodstream, where it begins to cause damage. This infection can lead to severe illness and death. Adults in many parts of Africa can become resistant to malaria. Children, however, continue to fall dangerously ill. Many years ago, researchers showed that you could take antibodies from the blood of adults who had experienced malaria many times, inject it into children, and by so doing, actually treat the disease. The catch is, blood contains millions of individual antibodies, and what has been difficult is to determine exactly which ones actually kill malaria parasites. This is what the SMART network set out to do. We decided to make KILChip, a protein microarray that would allow us to recreate the parasite on a simple glass slide. 3 major components were required. First, the malaria parasite material or proteins. Second, blood samples collected from humans who had been infected with malaria and had either become ill or were resistant to clinical symptoms. Lastly, a team of scientists who would bring the components together, process the samples, and analyze the data. We focused on the cycle of the infection that plays out in the bloodstream. This is when one begins to feel ill and gets progressively worse. Merozoites are entering red blood cells, growing and multiplying. Approximately 30 daughter merozoites burst out, destroy their obliging red cell host, and find new unsuspecting red cells in which to repeat the vicious cycle. We concentrated on proteins that antibodies could easily locate and made these at the KEMRI Wellcome Trust labs in Kilifi, Kenya. For the samples, we intentionally selected locations in Africa that represented the spectrum of malaria's varied intensity on the continent. These included Kintampo in Ghana, Dielmo and Diop in Senegal, Bandiagara, Sotuba, and Samako in Mali, Balongin in Burkina Faso, Muhiza and Rufiji in Tanzania, Nagongera, Kihihi, and Walukuba in Uganda, and Kombewa and Kilifi in Kenya. In a prime example of collaboration within Africa, scientists from these countries partnered to share samples from malaria cohort studies. In all, we assembled 10,000 unique samples. We now had KILChip and our massive sample set. In a show of extraordinary coordination and commitment, my team worked tirelessly to process the samples and generated tons of data. The biostatisticians are now crunching the numbers. Does this already give us the vaccine? No, it certainly does not. What it does do is help us to predict which proteins might be effective in a vaccine. We need to further demonstrate that these antibodies actually kill parasites and that they remain active for a long period of time. Thereafter, we can engineer vaccines to reproduce the same effect. Can we do it? Yes, we absolutely can. It will take collaboration, determination, and resolve. Together, let us make malaria history. Then they can't, yeah? So you can't say some people get infected by malaria parasites and others do not.
Oh, yes.
Yeah?
The Wakanda. What kind of scientist are you?
Official greetings.
Ni choir una conduct. It's a choir here.